Welcome back, students. In this video we are going to study equality of matrices, addition of two matrices, then scalar multiplication of a matrix A by a scalar quantity lambda, which is a non-zero scalar number. So very first definition, equality of matrices. Any two matrices, say Aij, whose order is m by n, and a matrix containing all elements Bij, P cross Q are said to be equal if and only if two conditions are satisfied. First, they have exactly same order. It means that the number of rows of first matrix should be equal to the number of rows of second matrix, and number of columns of first matrix should be equal to the number of columns of the second matrix. That means they have equal number of rows and columns. So number of rows and columns of first matrix, suppose first matrix has 2 rows, then second matrix should also have 2 rows. First matrix has 3 columns, then second matrix should also have 3 columns. This is the first condition. And second condition, they are equal only when each and every element, ith element of ith row and jth column is equal to the corresponding ith row and jth column element of the second matrix. It also means that A11 is equal to B11, A12 is equal to B12, then so on and so forth. Then A21 is equal to B21, A22 is equal to B22, and so on. Let us take an example. For example, these two matrices are equal. Obviously, the first matrix, it is having 2 rows and 3 columns. Order is 2 by 3. It is very clear that this is also having 2 rows and 3 columns. First condition is satisfied, and all corresponding elements must be equal. The first element A should be equal to the first element of this matrix. Second element B of first matrix should be equal to second element, that means first row second column element of the second matrix. The first row third column element, which is 4 in the first matrix, should be equal to the first row third column element, that is Y. So in this way we have got the equations that these two matrices are equal if and only if their order is same and corresponding A is equal to 0. Then we have B equal to 3. We also have Y equal to 4. Then we have C equals to 6. Then we have X equals 7, and then Z is equal to 6. So definitely it's very easy concept to understand. More questions will be discussed in the next video. Let us concentrate on the second topic. It is what? Addition of two matrices. Students, two matrices can be added or subtracted. Suppose we denote the first matrix as capital X and second matrix as capital Y. If I want to add these two matrices, then I'll have to put a plus sign in between them. What is the condition? Both the matrices should have same order. They should have same order. Then only they can be added up. The corresponding elements can be added up. For example, matrix X is having a matrix X. It has 3, 4, 5, and then A, B, C. This is of which order? This is of, what is the order of this matrix? Its order is 1, 2, 3, 3 rows and 2 columns. So and take another example, another matrix Y. It is having, say, 0, 1, minus 1, and 4, 5, 2. This is another matrix of same order as was of X. So let us add these two matrices. We write X plus Y is equal to add up 3 plus 0. That will come 3 plus 0. Then these corresponding elements we have to add a plus 4. You cannot add 3 to 4. You have to add corresponding elements. Similarly, the second row first column element should be added to the second row first column element only. Similarly, the second row second column element, which is b, should be added to the second row second column element, which is 5. Second row second column element, that is b plus 5. Similarly, the third row first column element is 5 over here, and in matrix Y, third row first column element is -1. So I will write -1. Similarly, C in the third row first column element, third row second column element should be added to the third row second column element, which is 2. So I will add C and 2 and write it like this, C plus 2. So like this you can see the addition of two matrices. So whatever is the answer you'll write it simplified form, this 3a plus 4, then 5b plus 5, then it is 4c plus 2. This is the resultant matrix. It is the addition of two matrices. If you want to have difference x minus y, then it's very easy. You have to just subtract y from x. So how will you subtract? So 0 from 3. 3 minus 0 is 3. That is a minus 4. Simply you have to write a minus 4. Similarly, you have to write 4 minus 1. So it is 3. Then we have b minus 5. It is b minus 5. So it is -1. The last element, last row, 5 minus of -1, that is 6. And c minus 2. It is c minus 2 simply. So this is as it is. This is the matrix. If they were numbers, then you directly write the final answer. Then one more topic, which is what? The scalar multiplication. What is a scalar multiplication of a matrix A? Just a minute. The third topic, scalar multiplication of a matrix A by a scalar number lambda. Suppose you have a matrix. Suppose we'll just draw a small line over here. Suppose you have a matrix P. It is a square matrix and we have what? Elements 1, 2, -1, 5. And if I want to find out twice P, then I have to multiply each and every element of this matrix with this scalar number. So what is the resultant matrix? Twice P will be 2 into 1, 2 into 2, which is 4. Then I have to multiply each element and then write the new matrix. It is what? -1 into 2, so -2. Then 5 multiplied by 2 is 10. This type of product, this type of new matrix, which is obtained by simply multiplying each and every element of the original matrix with a scalar number 2, is called as the scalar multiplication of a matrix P with a scalar number 2, which is a non-zero scalar number. It's very understood. If it would have been 0, then the whole matrix would have vanished. So what do we learn from scalar multiplication? Multiplication of a matrix by a number lambda. Suppose a matrix, there is a matrix, same matrix P, then multiplication of a matrix P by a number, scalar real number lambda, is nothing but is defined as multiplying each and every element of that matrix with that particular scalar number. So 1 multiplied by lambda is lambda, then 2 multiplied by lambda is 2 lambda, twice lambda. Then we have minus 1 multiplied by lambda, then it is minus lambda, and 5 multiplied by lambda, which is equal to 5 lambda. So students, I hope you have understood what is a scalar multiplication. Also you have understood the addition. All the three topics. Equality of matrices. Two matrices are said to be equal if and only if their corresponding elements are equal. This is an example which we have done. What is the condition? Basically their order should be same, and their orders should be same, and then corresponding elements must be equal. We'll write like this: same order. They should have same order and their corresponding elements must be equal. Then we have addition of two matrices. Two matrices of same order can be added up. If they have same order, then the corresponding elements can be added up. We have taken an example and seen how it is the two matrices are getting added up. A matrix of 3 by 2 order can be added up to another matrix Y, which is also of same order 3 by 2, and the corresponding elements are added up and form the new matrix X plus Y. Similarly, X minus Y can also be added. Why I have taken X minus Y under the heading addition? Because X minus Y is nothing but multiplying Y with a scalar number minus 1 and then forming a new matrix minus Y and adding that minus Y to this matrix X. Hence, this is 100% specific need. There was a need to understand scalar multiplication. Then scalar multiplication of a matrix with a scalar lambda can be easily understood with the help of this example. Then B, suppose there is a matrix P which is 1, 2, minus 1, 5, 2 by 2 matrix. Then twice P is nothing but 2, 4, minus 2, 10. Then if anyone asks what is minus P, then you can easily say it is nothing but minus 1, minus 2, 1 and minus 5. So this is how you can obtain the negative of matrix, and that is what we have done in X minus Y as well, and then we have added up. Then I hope you have understood the three topics: equality of matrices, addition of two matrices, and scalar multiplication of a matrix by a non-zero scalar quantity. So students, just like, subscribe and also share the same video. Thank you.